In this chapter, it's mostly about cars and trains. Mom, the trees are going backwards. And I'm like, hey, are you crazy? Trees don't move. We are moving. And why do it looks like that trees are moving backwards? Hello everyone, welcome to Diksha Vedantu and welcome to class 9th. I'm your physics teacher Aditi and today we are going to look at the chapter Motion of your class 9th Science. Okay, now this chapter is very interesting, not mostly based on experiments, although we do focus on experiments a lot. I'm trying to focus on understanding the concepts through experiments and reach them to you. But in this chapter, it's mostly about cars and trains. So I won't be doing the experiments in cars and trains, but I've used these kind of animations all throughout the PPT. So you're going to love it and you're going to understand it way better. Okay. Now your chapter, as imagine after your class 8th, you are going to your nani's house, your mamu's, your bua's house, okay? And you're going maybe through car or maybe through train. Now, one thing is maybe your younger brother or your sister, she shouts, Mom, the trees are going backwards. And you're like, hey, are you crazy? Trees don't move. We are moving. And she asks you, how do you know? And you're like, I watched the Diti ma'am's lecture. That's how I know that trees don't move. Also common sense. But in this chapter, we are going to actually decode what all these things are. Why do it looks like that trees are moving backwards? Something called relative motion. We will study that later. Okay. Now, starting the chapter, motion. Am I in motion now? Am I in motion now? I am in motion now. And I am now, I'm at rest. This is a basic definition of motion. So, first of all, let's understand the two types of motion, that is rest and motion, or will you say velocity and all those other stuffs. Now, this is, let's say me. This is me. I'm chilling, I'm watching TV, and then I am at rest. I'm resting, okay? I am resting. Now, my mom shouts from behind, like, Aditi, don't you want to study? Go and study. I'm like, no, mom, I am resting. I won't study. And then she comes, and then this is me or you and all of us. And now we are in motion. Basically, the gist of it. If you are stood, if your position is not changing, let's understand it more scientific wise. Okay. What is rest? When a position of an object does not change. This rabbit is just sitting and it's judging you for your posture. Or this man, it's just standing. That is rest. That their position does not change. It does not change. They are at rest. Now, for motion, it's actually position of object changes. Birds flying or someone who is cycling, they can't be at rest for long, right? You might have done championships among each other who can stay at bike at rest without paddling. So that is rest. When you're driving the cycle, when you're paddling, then you are in motion because your position is changing. First you're here, you pedaled and you reached here. So your position changed. Correct? Then, so these are some of the basic definitions of rest and motion. Now, let's go into a depth of it, how you have to write. Okay? Let's say this is a tree. This is a super fast car that your dad bought you. Okay? Or you brought yourself. Now, this position of this car does not changes with respect to time. With respect to time is very important. Yeah, here's the pen. So, see, let's say this is the time at 5 seconds, okay? Or let's say 0 seconds, okay? So this is the time at 0 seconds. But now your position changes. Let's say, or time changes, let's say 5 seconds. But the car is still here. You didn't move. You're so scared to drive the car. After 5 seconds, after 10 seconds, 8 seconds, your car is not moving. The distance of the car from the tree, it remains same. It remains same. Now, on the other hand, what's motion? So, motion, this is also now t equals to 0 second. Okay, t equals to 0 seconds. But look it very carefully. Now, the position here, whenever a body does not change its position with respect to time and stationary objects. So, here tree is my stationary object and this t is my time. So after 5 seconds, the car did not move with respect to tree. That means the distance of car from that tree remains same even after 5 seconds. Now look carefully. This is the distance of the car from the tree. But after 5 seconds, the car moved. After 5 seconds, the car moved. So this is t equals to 5 seconds. This was t equals to 0 seconds. Done? So at 0 second, the position of car with respect to tree was, let's say, 5 meters. But now, after 5 seconds, the car moved a distance of 10 meters. Okay, so position is changing with respect to time as well as with respect to stationary object. Now tree is a stationary object, right? Tree does not move. So that is the whole gist of rest and motion. Then let's move on to the next thing, that, my friend, is types of motion. Now there are 4 types of motion that we are going to study. First is straight line. So see very carefully, you will understand it very lovely, in a very lovely way. Okay. Now straight line is this. So the car is going literally straight. It's not turning back. It's not turning right, left. It's going straight in a straight line. Then this is a circular motion. So it's a little bad, but the car is moving in a circular path. The car is moving in a circular path. So this, my friend, is circular path. That was straight line. Now rotation. What is the difference between rotation and circular path? See here, if I go like this, then it is circular path. But if I stand here and rotate and start rotating like this, then that is rotation. So understood, this is the circular path. Let's see again. This is your circular path. So car is not moving on its axis. Car is moving in a circle. What is rotation? The person who is rotating on its own. Okay, I'm a belly dancer and I'm rotating around. Okay, then we have vibration. You have seen alarm clocks, right? Or your phone vibrates. You're a new generation, I forget. Your phone, it vibrates. So that this motion, this vibration is called vibration. So we have 4 kinds of motion: straight line, circular path, rotation and vibration. Then understood? Okay. Then moving on to one more thing. Ma'am, you understood, you told us rest and motion. Now, I'm not moving. This is me, I'm resting. I'm eating my popcorns. Okay, I'm not moving. So I'm at rest. I'm definitely at rest. But there is one very important thing that you all are forgetting. What is this? This is my solar system. This is my sun. This is my earth. Now, I am on this earth. I am sitting on this earth. But this earth is moving around the sun, right? This earth, it is moving around the sun. So that means when I say that I'm not moving, I'm not actually at rest, because the earth is moving around the solar system. Earth is not at rest. So in a grand scheme, if you zoom out, earth is moving, and hence I am living on earth. So I am also moving. That is why I say that is why the definition of motion, look at this carefully, the definition of motion is not when a body does not changes its position. It means that it actually says whenever a body changes its position with respect to stationary objects or time. This board is a stationary object. If in 1 second I go here, then I change my position with respect to time, with respect to board. I was at rest with respect to board because I was not changing my position, right? With respect to board, with respect to time. But actually, I am changing my position in a grand scheme, right? So if you don't write with respect to stationary objects, then that's an incomplete definition. So you have to write with respect to stationary objects and time. Okay, understood all these. Now let's move on to a little bit better topic. That is, when you were going to your nani's house, someone came to drop you at the train station, or someone waved you, maybe your dadi waved you when you sat in the car and you went away, right? Now, and your mother is sitting right next to you. According to your mother, your father asks, where is your mother? Oh, she's sitting right beside me. She's at rest. She's not moving. Right? But according to your dadi, who's standing there and waving, you both are moving. right? So for her, your mother is moving. For you, your mother is not moving. Your mother is at rest. Ma'am, what kind of dilemma is this? This, my friend, is called relative motion. This is called relative motion. That means it is the motion of an object with respect to another object or observer. In case of me, my mother was sitting right beside me and she is at rest. Why? Because I am an observer. I am also at rest. But the whole car is moving. But inside the car, we are both at rest. And if I am at rest, if my mother at rest, but we are both moving in a grand scheme, but we both are at rest with respect to each other. With respect to each other. But for my dadi, we both are moving. So if dadi is the observer, we are in motion. If I am the observer, my mother is at rest. Understood? Got the gist of it? Understood? You'll understand it slow by slow, okay? Step by step, because this is very new to you. You've just passed 8th, entering into a 9. You're in that era of being a senior, right? Give it time. Also start studying. Give it time, okay? Watch this one shot. This is going to be very interesting. Okay. Now, so motion is not absolute. That means you cannot define motion with one single definition that that person is at rest. That person is in motion. No. You have to say that person is at rest with respect to me. But that person is in motion with respect to my dadi. Done? It depends on who is observing. If dadi is the observer, she is in motion. If I am the observer, she is at rest. Understood? Very clear, crisp, clear. I told you I'll teach you in such a way that you will not ever forget motion. Trust me, I promise you that. If you don't understand it in your class, in your school, and you're like, what is this relative motion? How can one person be at rest and motion? Just watch this one shot and you will be fine. Okay. Next we have, now let's dive into a little bit of physics, a little bit of science. Okay, because that's why we are here. Now, uniform motion. Let's understand from this diagram first. Now, every morning a bus comes to pick you to get you to school. Okay. Now, this is your house. Let's say, okay, this is your house. We named that guy Rohan actually. So let's say this is Rohan's house. This is Rohan's house, and Rohan is not ready. So her mother is like, Rohan, come on, bus is out there. So bus is about to leave, but then Rohan is like, okay, I'm coming. So Rohan sits in this bus, hops in this bus, and the bus starts moving. What happens? Now the bus reaches at a point that is 20. First it was at 0. It was at 0. Now it is at 20. Just focus at the center. Okay, just focus on the center. Now it is at 20. Now the bus moves. Now the bus is at 40. Focus on the center. The bus is at 40. And even the bus moves further. Now the bus is at point A, which is the point 60. Let's just write it down. Okay. So we got 4 values. First, the bus was 0. Wait a second. Yeah. So first the bus was at 0 distance. Then it covered 20 meters. Then it covered 40 meters. And then it covered 60 meters. Now, let's say this bus was going, it was taking, let's say 50 seconds or 10 seconds for every house. Okay, when it was at your house, the time was 0 seconds. We just started counting. Then after 10 seconds, the bus reached second house. Then after 10 seconds, the bus again reached 40 meter house or the third house. Then at the third distance, time, after 10 seconds, the bus reached the third house. That is 60 meters away. Done? Understood? Okay. So now here the time was 10 seconds. Plus 10 seconds, this will be 20 seconds. Plus 10 seconds, this will be 30 seconds. So can you guys plot the graph of this? Can you guys plot the graph of this? Let's say. Now on the x-axis that you will definitely study in math, on the x-axis will keep time. On the x-axis there is time, and on the y-axis we have distance, right? So let's say this is 10, this is 20, 30, or let's say we will not use 10, 20, 30. we'll use the intervals of 20. Okay, so this is 20 meters, 40 meters and 60 meters. And here we have time and 10 interval, right? So this will be 10 seconds, 20 seconds and 30 seconds. So initially distance was 0. That means somewhere here, and time was also 0. So somewhere here. As the time increases by 10 seconds, distance increases by 20 seconds. So the next point will be somewhere here. Then 20 and 40, 20 and 40. The next point will somewhere be here. And then 30 and 60. So the next point will somewhere be here. So if you join this becomes a straight line. It becomes a straight line. Okay, and this is what the graph of uniform motion looks like. That means, carefully listen, the bus is traveling equal distances 0 to 20, 20 to 40, 40 to 60, 20 meters. So the bus is traveling equal distance in equal interval of time, 0 to 10, 10 seconds, 10 to 20, 10 seconds, 20 to 30, 10 seconds. So let's read the definition again. The type of motion in which the object, that is our car or our bus, covers equal distances in equal interval of time. Easy. Understood? Now in uniform motion, the speed of the object remains constant or equal because it is traveling equal distance in equal interval of time. We'll study that later. Okay? Now let's move on to the one more very important, that is non-uniform motion. First we studied uniform motion. Now we are going to study non-uniform motion. Now be very careful. Let's see. Again, the bus is there to pick you up, to get you to school. Now, the second house is not at 420, it is at 25. It is at 25. It starts from 0. It reached directly at 25 meters. Then it reaches just 35 meters. You and your friend lives very close by. So from 25 to 35 in next 10 seconds. And then in next 10 seconds, it reached directly to 60. So what are the table values we got now? The time interval is exactly the same. Okay, it is still taking the time as 10 seconds. So first it started at 0 second. At 10 seconds, it reached the second house, which was at 25 meters. Then it just went to 35 meters in another 10 seconds. Then it directly went to 60 in another 10 seconds. Understood? So the time is still the same. It is still taking 10 seconds to go from one house to the another. But now the houses are not at equal distances. They are different distances away. First is 25 meters, 35 and 60. Okay. So you have to write time as 20 seconds and 30 seconds. Again, let's make the graph now. Let us make the graph. Now again, at y-axis we had distance. At x-axis we have time. Now time interval is same. This is 10 seconds, 20 seconds and 30 seconds. But distance now, see, interval we will take the same. So here that is 20, 40 and 60. Okay, but now we have 25. So little above 20, that will be somewhere here, we'll have 25, right? So at 10 seconds, it reached not 20, it reached 25. Then in another 10 seconds, that is 20 seconds, it reached 35, that is below 40. Somewhere here, this will be 35. So this will be the point. This will be the point. And at another 10 seconds, it directly reached 60. It directly reached 60. So this is the next point. Now if I plot, it won't be the same graph. It won't be a straight line. It is somewhere higher or below. It is not a straight line. Correct? So that means the distance is very different. The time is still the same, but this distance covered is different. Let's read the definition now. The type of motion in which object or car covers unequal distance 0 to 25, 25 to 35, 35 to 60, unequal distance in equal interval of time, 10 seconds. Made sense? Everything is making sense now. So in uniform motion, the speed of object does not remain constant or equal. So before we were covering equal distance in equal time, so speed was same. But here the distance is sometimes too much and sometimes very less. So the speed is also not the same. Correct? It's not constant. We'll study about speed in just a minute. Okay, let's move on to the next part, a little bit physics of uniform motion and non-uniform motion. What are the examples of it? Okay, so uniform motion is motion of hands of a clock. You have a clock in your house. The hand, the 60-second hand or the minute hand or the hour hand, they are all traveling at equal distances, that is that full circle in equal interval of time, that is 1 hour, 1 second, 1 minute, right? Understood? Then you have motion of train at a constant speed between two stations. Now, when we are talking about train, we are not talking about that it accelerated and then it stopped and then again accelerated. No, we picked 2 points and we said that in between those 2 points, the speed of train is same. It is not changing. It is 20 kilometers per hour. That's it. It is not going to 30, not coming back to 10. 20 kilometers per hour. That is an example of uniform motion. Then motion of planets around the sun. Although that's a tricky example, but for now that you're in 10th, the motion of planet around the sun is also a uniform motion. Okay. Now next is non-uniform motion. What are the examples of that? Motion of a car on a busy road. Imagine you are going somewhere and there is traffic, there are red lights, so you stop your car, and then there is no traffic, it's highway, so you speed up, you accelerate. So it is not a uniform motion. Your speed is not same, right? Sometimes your speed is 0, sometimes your speed is 10, and when your father sees that there is no traffic, he accelerates, and sometimes your speed is 60, 70, right? So the speed is changing. That means non-uniform motion. Then motion of a ball dropped from a height. As soon as you drop a ball or any object from a height, it will accelerate towards the earth. The gravity will pull it towards the earth, towards the center of earth, and it will continuously accelerate. You'll study that about, okay, you don't have gravitation now, right? It was a bit related to gravitation. That's why they had this example in this chapter. But for now, just imagine that something you drop and accelerate towards the ground. That's it for now. Okay, let's move on to one very important thing, that is quantities. Now this is where the actual physics start. There is something called scalar quantity. There is something called vector quantity. And I have done masters and I have read about these in masters as well. So this is as important. Okay. So scalar quantities, imagine you are saying to your friend that I'll go home now. Okay, I'll go to my home, and that is, my home is 5 kilometers away. So you are just giving the distance, right? And your friend says, my home is also 5 kilometers away, but it is towards right, or it is towards north. So what he is doing, he is also giving you direction with the magnitude, with the distance to your home. He is also providing you an extra information, that is your direction. It's towards east, it's towards north, right or left, right? So that extra quantity, when you add that extra quantity with your magnitude, that, my friend, is vector quantity. Let's study about it again. Scalar quantities, quantities which have magnitude but no direction. The information you gave was what? My house is 5 kilometers away. So it was just the 5 kilometers, just the magnitude of distance, not the direction, right? Now, money does not have any direction. Time does not have any direction. Time has a direction although, but it cannot go backwards. So you cannot say it's a vector quantity because time does not have the option to go backwards. It can go towards one direction only. So you don't have to define its direction. We know it's moving forwards. So it's a scalar quantity. Mass, you just say 5 kg. You don't say 5 kg upwards or 5 kg right. Don't, right? Distance is also a scalar quantity. Now, how distance is a scalar quantity? We'll study in a bit, because giving direction and not giving direction, both are very different things. Before that, let's study vector quantity. Now, if the quantities which have both magnitude and direction, those quantities are called vector quantities. Now, these are a little bit high physics quantities, which are force, velocity, weight, acceleration. We'll study them just in a bit. Just wait. Okay. Now, moving on to scalar quantities, we discussed distance. Now there is one more thing called displacement. Distance and displacement are very different things. How? Let's see. Now imagine this is the graphs you are given, and your father used to maybe tell you that you don't know how hard the path to a school was. We used to cross mountains or rivers or maybe oceans to reach the school. So your father is here, okay, and your school is somewhere here. Your father is here and his school was somewhere here, and he used to travel all these distances. Let's say this was 3 kilometers and this was 5 kilometers. So the total distance becomes what? 3 plus 5. So the total distance becomes 8 kilometers. And then you got up and some development happens and there becomes a tunnel from your house to the same school your father went. So now this is you with your infinity aura, and this is your school, right? Same school. But now you have this tunnel, and this tunnel is merely 4 kilometers. This is 4 kilometers long. So this is the shortest path to your school. Your father used to travel this long path because he didn't have the access to the tunnel, but you have the access to the tunnel, and the tunnel decreases the distance significantly from 8 kilometers to just 4 kilometers, half the distances. So the shortest distance between 2 points is actually called displacement. And let's study a little bit more scientific terms about displacement and distance. Then we'll come back to that circular problem. Okay. Now, actual path, you're standing here and you're going till here. So this whole path from here to here, this whole path is the actual path covered when we travel. If you go by a car or by a bike, you'll have to move through these turns, right? And this is a scalar quantity because this doesn't have a direction. When you say my house is 5 kilometers away, that does not include direction. So that is your distance. And it can't be 0, as we say, I traveled 0 distance. That doesn't make any sense, right? So you can say I was at rest. You don't have to mention distance. So it can't be 0. It cannot be negative as well. I went minus 5 kilometers to my house. No, there is nothing like that because this is a scalar quantity. How do you relate it to displacement? Then you'll understand it better. This is the shortest distance. We just studied that tunnel gave you an access to shortest distance to your school. So the shortest distance between 2 points, that is your initial point and final point, is called displacement. It is a vector quantity. With the displacement, every time you write something that 5 kilometers towards right, 5 kilometers towards north, every time you mention a direction, you will say that this is displacement. Or every time you talk about displacement, you will have to mention a direction with it, okay? And it can be 0. Now, how it can be 0? Imagine this is a circle now, okay? This is a circle and you start here and the radius of this circle is, let's say, 2 kilometers. Okay, 2 kilometers. Now what you went here? You went through this whole path. Let's say you're jogging and you come back to the same point. Okay, you come back to the same point. Then let's say the app you're using to cover the distance, it will tell you the total distance that you traveled, right? The total distance will be the parameter of this whole circle. That will be 2 pi r, 2 pi into radius, 2 pi into 2 kilometers is the radius. So 4 pi kilometer is the total distance your app will show you, that this is the total distance you traveled. Okay, so it is not 0. Even though you came back to the same point, your distance is not 0. But on the other hand, when you study about displacement, so it is the shortest distance traveled, shortest path followed. Now again, you are standing here and you started jogging and the whole circle you covered, you came back at the same point again. So this is your initial point and this is, my friend, is also your final point. This is both your initial point and final point. And displacement is what? Shortest distance between initial point and final point. Both your initial point and final point merged. So what is the shortest distance between them? Shortest path between them? 0. Nothing, because they are at the same point. So that's how your displacement can be 0. If you start at a point and you come back at the same point after running even all the distance, but your final and initial position is same, that means displacement is 0. So it can be 0 and it can be also negative. How? Let's say I say that I move towards right for 5 kilometers. Then I turn back, I move back to the same point. Now the displacement is 0. But I keep on moving towards left for another 5 kilometers. So my direction changes. I was going towards right, I came back, 0 displacement, but I keep on going in the left direction. So that left distance, that will be now a negative value, that will be minus 5 kilometers. Say I started from here. Okay, I started from here and I went till here. This was 5 kilometers. Then I came back. So now my displacement is 0. But I keep on going and I go to this point. So this was the positive distance. This was the 0 distance. And when I go back, this became negative displacement. Okay, understood? Because from the final and the initial point, you went backwards. And when you go backwards, that is your negative distance, your displacement. Understood? Next, moving on to another very important topic, that is your speed and velocity, which are correlated to distance and displacement. So speed is simply, you have a very basic definition of speed, that is distance traveled per unit time. When you say, okay, I have to go to this part of Delhi from Noida. So from Noida to Delhi, you reached in 5 kilometers and the distance was 40 kilometers. You reached in 5 hours and the distance was 40 kilometers. So what is your speed? Your speed will be, you traveled 40 kilometers in 5 hours. So what your speed will be? 40 divided by 5. Because your speed is distance upon time. That means how much distance you traveled in what time. So your distance was what? It was 40 kilometers and your time was 5 hours, right? Although that's a very high time, but let's say there was lots of traffic. So you traveled 50 kilometers in 4 hours, and if you divide those, it will come out to be 8. So 8 kilometers per hour will be your speed. Your speedometer in your car shows that you traveled 8 kilometers in 1 hour. And since you went for 4 hours, 8 multiplied by 4, it will be the total hours. Okay, done? Understood? Now, why we calculate speed is basically we use that all in our cars. The speedometer actually gives us the average speed, and we'll talk about that too. So this speed is clear. It's the distance you traveled in a particular interval of time. Then it is also a scalar quantity because we mentioned distance traveled per unit time. So distance is also scalar. When you divide it by time, which was also scalar, so the quantity comes out to be scalar quantity, and the unit, SI unit, the SI unit will be meter per second. Total distance traveled by the total time taken will be your speed. That will be distance in meters, time in seconds. Okay, very normal. So the SI unit is meter per second. Now moving on to velocity. Now speed and velocity are very different things. Do not confuse them, because in the further questions you will be asked mostly velocity, less speed, but if you want to clear JEE and stuff, they'll ask you speed questions as well. But for now, they'll mostly focus on velocity. Okay. Now here it was a distance per unit time. Here on the other hand, it is displacement of a body per unit time. That means the shortest distance traveled in unit time, in that small time, is called velocity. Again, you are coming to Noida, from Noida to Delhi, but now your father knows a very shortest path. Okay, now he travels from there, he gets your car from there and he reaches very early. So that shortest distance, when you come from that shortest distance, the speed will be maybe more, maybe less. That's a different point. But if you travel through that shortest distance, then that will be your velocity, not your speed. Understood? So displacement of a body per unit time is your velocity. So velocity formula is almost similar to speed as well. Here speed we have distance upon time, velocity we have displacement upon time. Now remember, we studied that displacement was a vector quantity. You have to mention the direction whenever you are writing displacement. Now if you divide displacement by time, again velocity is a vector quantity. You'll again have to see that I went from Noida to Delhi, but through towards north or towards south, towards east. Okay, so you have to mention the direction along with the value of velocity, and the SI unit is same, meter per second, because at the end we are only traveling, we are covering a path, we are covering a distance in kilometers and meters. So both units of both velocity and speed are meter per second. Speed is a scalar quantity. How you can remember? Just S of speed, S of scalar. So speed is a scalar quantity. V of velocity, V of vector. Velocity is a vector quantity. Very easy. Shortest distance traveled per unit time is velocity. Normal distance traveled per unit time is called speed. Understood? Okay. Next we have, let's do quick, very easy question. I'll use this for the question. Okay, now let's understand this question very carefully, and whenever you read, you'll start writing. Okay, see, Usha swims in a 90-meter long pool. So this is a 90 meters long pool, and what they're telling, she covers 180 meter in 1 minute. She covers, so that means she went here and she came back. So this total distance after she comes back here will be 180 meter. So the total distance she traveled was 180 meters. Done. In 1 minute. Time is also given. So time will be 1 minute, or you can write in 1 minute we have 60 seconds. Done. By swimming from one end to the other end and back along the same straight path. Then she started from here, went till here, then came back the same path covering 180 meter distance. Now find the average speed and average velocity of Usha. So first we have to find average speed, then we have to find the second, we have to find average velocity. Now let me know the formulas in the comments as well. Slide number is 34. Okay. But I'll do that as well. Let me know the answers. Solve it yourself. It is very easy. We just saw the formulas of average speed and average velocity. You just have to use those formulas and that's all. But there's a trick in the velocity part. So make sure you are keeping that in mind. Okay. Now average velocity was what? Total distance divided by total time. Total time. Understood? Now total distance she covered was what? It is given 180 meters. So total distance is 180 meters. Total time is what? Total time is 1 minute or 60 seconds. So with meter we'll use 60 seconds. Correct? So if you just cancel these, 3 will be 18 and 3 meter per second will be your average speed, my friend. Done? Understood? Now the tricky part comes. The tricky part is, now you have to find velocity, average velocity. How will you find average velocity? Let's just look at this for a moment. When they say that she came back along the same straight path, if she started from here, she went till here 90, she came back 90. So the distance is 180. But you know, she came back to the same point, and when initial and final point are same, average velocity we are finding when initial and final point are same, right? She started from one end, she came back at the same point again. So initial and final points are same. That means displacement is what? Displacement is 0. Displacement is 0 meters. Understood? Now what was the formula of average velocity? It was total displacement by total time. Understood? So total displacement is what now? It is 0. Time is whatever. She still took 60 seconds to cover it. And this, my friend, will be your average velocity, which is equal to simply 0. 0 divided by anything will be 0 meters per second. You want to add or you don't want to add, it doesn't matter. But average velocity will be 0. Average speed, on the other hand, is 3 meters per second. Understood? Clearly understood? Okay. Now, let's move on to the next concept, that is your acceleration. Let me go back. Yes. Now, moving on to acceleration. Now, I mentioned the word accelerated again and again in this whole conversation. That was due to some reason. So, why? Because we say that accelerate the bike. You and your friend are in a car. Okay, and he says, bro, let me show you how fast this car goes. So, what he does, he'll push the pedal down, and the car will go straight. Something like this, right? Something like this. The car will go straight, right? And the speed will keep continuously increasing. So that change in speed or change in velocity per unit time. Change in velocity per unit time, because the car is continuously speeding up. So its speed is increasing, its velocity is increasing per unit time. That is called acceleration, or you can also call it rate of change of velocity. Whenever anything is divided by anything, the change of anything is divided by time, we call it as rate of change of that particular quantity, which is here velocity, or change in velocity per unit time, rate of change of velocity. Then now we have one more topic, that is before that, let's just mention what is here. The acceleration, the SI unit of acceleration will be what? See, this is change in velocity. So the SI unit of velocity is what? Meter per second, and the time is also second, right? So that is meter per second. You can write it as meter per second into second. That is meter per S into S square. So the SI unit of acceleration is meter per second square, or you can also write it as meter S minus 2. Understood very clearly? Now this acceleration is change in velocity. And now velocity is what? Is it a scalar quantity or a vector quantity? Is it a scalar or a vector quantity? Let me know in the comment section. Is the velocity scalar or vector? And hence, what will be the acceleration? Will it be a scalar or will it be a vector quantity? Acceleration. Okay. Next, moving on, we have retardation. Now, moving on to retardation. What is retardation? See, your friend, and now you're sitting in a car, right? So you go, okay, let me drive. I want to also give it a go, but you don't know how to drive a car. But you're like, no, I don't know how to drive a car, but let me try. Okay, so you sit and hold the wheel, and this is something happens. What happened? Happened is you actually did not know how to drive a car. So what you did, as you accelerated, you tried to accelerate, but the car stopped. Maybe you didn't let the clutch go very easily, or you pulled the brake, you pushed the brakes, and that's why the car stopped. That means, first of all, when you started, velocity increased, and then velocity decreased to 0. Understood? Velocity at some point, let's say when your car was here, let's say your car is here. Oh, what kind of car is this? Okay, your car is here somewhere. Okay, now this was here, the velocity was 0. You didn't start. Then the velocity is now, let's say, 5 meter per second. You are accelerating, but then you started stopping. You start stopping, and until you reach here, the velocity again becomes 0. Now the final velocity is 0. Initial velocity is 5 meter per second, which we write by u. We write initial velocity by u and final velocity by v. So initial, from this point, leave it here. You didn't start. I am seeing you midway. I am seeing you, this A guy is driving. It stopped. So the minute I started to see, your velocity was 5 meter per second, and then it stopped, and the final velocity became 0. Understood? Now, this is called retardation. When your velocity comes to an end, when your velocity becomes 0 or it decreases. When your velocity decreases is called retardation. When velocity increases, it's acceleration. When it decreases, it's retardation. No. When your car stopped. Okay? So this is the whole point. Again, the SI unit will remain same, meter per second square. And this you have to tell me in the comments. Answer in comments. What will be the SI? Which quantity will be the acceleration? A vector quantity or a scalar quantity? Scalar quantity. Okay? Okay. Let's move on to a very good numerical. Let's see. The first, starting from a stationary position, Rahul pedals his bicycle to motion to attain a velocity of 6 meter per second in 30 seconds. What are they saying? See, as we read, we write. Okay. So what is given? In the first case, in the starting, there is a starting from a stationary position. That means the Rahul is first at rest. This is Rahul, and the Rahul is now at rest. At rest. So its velocity will be what? Its initial velocity will be 0. Right? So initial velocity, let's say this is the first case, initial velocity is 0. Then the velocity, it pedals, it starts pedaling and the velocity goes to 6 meter per second. So now the final velocity is 6 meter per second and the time is what? It is 30 seconds. Understood? Now, then he applies brakes such that the velocity of bicycle comes down to 4 meter per second. He was here, first he reached here and the velocity became 6 meter per second. Now after some time he again went far and the velocity become, he was driving some cycle, okay, and now the velocity becomes 4 meter per second. He applies brakes. Understood? So you understand the question? Understand the question. First he started from rest. So the first is the bike started from stationary, then it reached to a speed of 6 meter per second and then it stopped it went back down to a speed of just 4 meter per second. So this will be your first case, this will be your case 1 and then this will be your case 2. Understood? Now what is the case 2? Case 2 says, according to case 2, it starts from here, right? Now the speed is 6 meter per second, but that is your initial speed, okay? And the final speed in here will be 4 meter per second in the next 5 seconds. So time in here will be 5 seconds. We need to calculate acceleration of the bicycle in both the cases. So let's start with the very first case 1. Okay, in case 1, u was 0, v was 6 meter per second and time was 30 seconds. So we know the formula of acceleration, right? We know the formula of acceleration. Final velocity minus initial velocity divided by time. V minus u divided by t. So acceleration will be v minus u divided by t. So v is what? 6 meter per second minus u is what? 0 meter per second and t is what? 30 seconds, right? So that is 6 divided by 30. Understood? 6 meter per second, 30 second and then you divide it. So the answer comes out to be 0.2 meter per second square. Don't forget to put a square in front, over the second. Okay, so this will be your acceleration in the first case. Now look at the second case, case number 2. Now in case number 2, we have u equals to 6, v equals to 4, time equals to 5. Simply v equals to, u equals to what? U was from the case first, second, final velocity will be case 2, initial velocity. So v will be 4 meter per second and time is 5 seconds. Again, you put the formula of acceleration, v minus u divided by t, which is 4 minus 6 divided by 5. Now this will be minus 2 by 5. That is minus 2 divided by 5. Now if you cut it, this will be 0.4. Correct. So you can either write a equals to minus 0.4 meter per second square. This can be your answer, or to be a better person, to be a better student, you can write that retardation. We studied retardation, right? And here the bike is stopping. So this is not acceleration. This is retardation. Why this is true? Because there is a negative sign in front of minus 0.4. So if you don't want to write minus 0.4, if you just write 0.4 meter per second square, then also it will be true, but very important point, then you have to write retardation. If you are writing acceleration A, then you have to put a negative sign in front of your final value. Okay, understood? So these two are your answers to this very important question. Okay, let's move on to the next. Now this is a very important topic of this whole chapter, that is graphical representation. We studied distance, we studied time, we studied speed, velocity, displacement, right? But how these things vary with the time. We studied about uniform motion and non-uniform motion as well. So let's look at all those through a graphical representation, and make sure you're watching this very carefully, because a lot of students lose their marks just in graphs. So I'll make you understand in a very good way. So, but be very focused. Okay. Now, on x-axis, we'll have time. On x-axis, we will have time. On y-axis, since it's a distance time graph, on y-axis, we will have distance, or I will write distance by s. Okay, I will write distance by s, and x-axis will have time. Now, let me know when I have a stopwatch. Okay, now you want two things. You have a stopwatch and a bicycle, let's say. Now, you are sitting on a bicycle and you start the stopwatch, but you don't move. Then what do you say? I am at rest. You are not moving, but the time is moving. Then what do you say? I am at rest. Or let's say this is the starting point and you are here 2 meters from the starting point, and you start the stopwatch again. Now also you are not moving, but you are still 2 meters away from the starting point. You have some distance, but you are not moving. So you are at rest. So let's say the distance you are at is 2 meters. Right? Now time was moving 1 second, 2 second, 3 second, 4 second, but you are at 2 meters. You are not going above, you are not going far, you are not coming near. So this will be your graph. A straight line, distance remains 2 meters only, but the time is continuously increasing, because time never stops, my friend. Okay, then again we'll have time on x-axis, distance on y-axis. 1 second, 2 second, 3 second, 4 second. Okay, so this is in seconds. Now this is a uniform motion. Uniform motion means equal distance or displacement in equal time. Okay, so that means you are covering 10 meter in first second, then another 10 meter, that means 20 meter you reached in another second, then you reached 30 meters, then you reached 40 meters. Now in the first second you went to 10 meter, so this is where you are. Okay, and in the second meter you went to 20 meter, this is where you are. In the third second you went to 30 meter. So see, the difference is just 30 meters. Difference is not increasing, but you are increasing. In 1 second you are covering 10 meter. In 1 second you are covering 10 meter. In another 1 second you are again covering 10 meters. Understood? And this will be now your final graph. The graph is a straight line. The graph, my friend, is a straight line. It is a straight line increasing with increasing slope. We'll see what slope is as well, do not worry. Okay, next, let's see the next graph, that is non-uniform motion. Non-uniform motion means unequal distance in equal time. In equal time. That was my non-uniform motion, remember? So this is time t, this is distance s, right? Now 1 second, 2 second, 3 second, 4 second, and here also you have 10 meters, you have 20 meters, you have 30 meters, you have 40 meters. But let's say at 1 second you didn't move any distance. You are here, as the second goes, you reached 10 meters. Okay, fine. At 2 seconds, from 1 second to 2 seconds, in the next second, you sped up, you accelerated, and you reached directly to 30 meters. Okay, you reach directly to 30 meters. And then at the third second, in the next second, you are like, okay, I'm going too fast. Then you just reached another 10 meters. So here the difference is 10 meters. Here the difference is directly 20 meters. 10 meter reached 30 meters. Difference is 20 meters. And you're like, slowed down. The distance is now just 10 meters. So this will be your graph now. This will be your distance time graph now. Understood? It is not a straight line. Not a straight line. So it's at rest, you will have your distance is not changing. Uniform motion, you will get a straight line. Distance is changing continuously in equal interval of time. And in non-uniform motion, distance is not changing continuously. It is not changing in equal interval of time. Understood? Okay, let's move on to now the velocity time graph. Velocity time graph, there it was distance time graph. So here we had distance. Here again in the x-axis we'll have time, but on the y-axis now we'll have velocity. Understood? So here 0, 1 second, 2 second, 3 second, 4 second. But here is our velocity now. Okay. So this will be 10, not just meter per second. 20 meter per second. 30 meter per second and 40 meter per second. Understood? I'll just show you the first one very carefully. Next I'll not take much time. Okay. Now see. You are at rest. Okay, you are at rest as it says. Now you turn on the your stopwatch. You click your stopwatch and you are not moving. Then what is your velocity? Your velocity is 0. However, in distance time graph also your velocity was 0, but distance can be something. You can be at 2 meters. But if in velocity time graph, even if I am 2 meters away from the origin, I am still at rest. Velocity is still 0. In case of rest, the velocity will always be 0. So the graph will not be here or here at any point. It will be simply at 0. How? See, the time is increasing. Now the time is 1 second, time is 2 second, 3 second, but velocity is 0. Velocity is not increasing to 10 or 20 or 30 or 40. It is always 0. Understood? Next, moving on to uniform motion. Again, we'll just give these x-axis. This is time, this is velocity, 10 meter per second, 20, 30 and 40. Now, see very carefully. We get uniform motion. That means equal distance in equal interval of time. Let's see this graph, right? Same graph, equal distance in equal interval of time. Now, what is velocity? Velocity is distance upon time. Velocity is distance upon time. See this very carefully. Velocity is distance upon time. Now, I have a graph. This is 1, 2, 3 and then this is 10, 20, 30, right? This is distance time graph. Distance time graph. Understand this very carefully because it will be very confusing after that. Okay, if you don't. Now this is time, this is distance. Now in first second I am at 10 meters. In second I am at 20 meters. In third second I am at 30 meters. So this is the graph. Okay, of uniform motion. Now understand this very carefully. Let's just see this case. From 1 to 2 second. From first second to 2 second. The time is what? Time is 1 second. Right? Now initial distance, initial point is what? Initial point is, my friend, 10 meters. Right? And final point is what? 20 meters. Right? So velocity is what? It's not actually distance. It's change in distance or change in displacement. Let's write. Okay? Change in displacement per unit time. That means final point minus initial point divided by time. Understood? Now final point is what? 20 meters. 20 meters minus initial point is 10 meters divided by 1 second. So that comes out to be 10 meter per second. So velocity in the first case comes out to be 10 meter per second. Understood? Let's see one more case. This second case, 2 to 3 second. From 2 to 3 second, now the time is what? Now the time is again 1 second. 2 to 3 second, time is 1 second. Now the initial point is what? Initial point is, ma'am, 20 meters, right? Initial point is 20 meters and final point is 30 meters. Final point is 30 meters. Again, let me put the formula. Till here, we have again V2 equals to change in displacement by time. Final point minus initial point divided by time. But now final point is 30 meters minus initial point is 20 meters minus divided by time is 1. So this will also be 10 meter per second. So you are looking at the stuff. Understood? This is for uniform motion. That means the distance and displacement is changing with time, but velocity remains the same. So that we also call it as constant velocity. Uniform motion is also known as constant velocity, and in here if the velocity was 10, right? So it will always be 10. It will always be 10. Understood? Clear? Now, uniform motion, now the velocity will not be same. Velocity will not be same. 1, 2, 3, 4, 10, 20, 30, 40. So, velocity will not be changed. Okay, sometimes it will be 10, but you accelerate it. You speed up. And now, velocity is 20. Now, you are like, no. Take it down. The velocity is again 10. Okay. Now you're like, okay, speed up again. Now velocity is directly 40. So this is non-uniform motion. That means velocity is changing. Here, changing velocity. Understood? It can be curved. It can be curved like this. Okay? It can be curved. Or one more thing I want to tell you is this velocity. See, in both the cases, the velocity is increasing as well. The velocity is decreasing as well. So make sure the velocity can decrease. Okay? But distance cannot decrease. Right? Distance time graph, distance can only increase. Distance can only increase or be at same point. This is this. But it won't be negative. You won't, when you go to a burger shop, you're like, okay, let me come back. The distance will decrease. But your speedometer, your bike will still show that you go for 5 kilometer and you just came 1 kilometer back. It won't say now 4 kilometer reading, right? It will say 6 kilometer because distance is always increasing. Displacement, however, can decrease. Distance can't. Velocity can decrease, but distance can't. Okay, but we have two more cases of velocity. That is, first is uniform acceleration. That means velocity is increasing continuously. Velocity is increasing in equal intervals in equal time. So this is time, this is velocity, and this the same values, okay? But this time the velocity is not changing randomly. It is first second it was 10, second second it was 20, third second it was 30, and fourth second it was 40. So it is continuously increasing, and this will be a straight line. Okay, that is your uniform motion. That acceleration is continuously, velocity is continuously changing. It's increasing in equal intervals. First it was 10, then it was 20, 30, 40. Then moving on to non-uniform acceleration. Okay, one more thing in here. Yeah, so this we studied retardation as well. That means velocity is decreasing, right? So you were started at 40 in 0 seconds and now it got 30, then 20, then 0. So this will also be a graph of uniform acceleration. This will be your acceleration. This will be your acceleration. However, this will be your retardation. Done? Okay. Next we have non-uniform acceleration. What does this mean? Acceleration is not increasing in equal intervals. If we take the same graph for time and velocity, 10, 20, now you'll see that at 0 second the velocity is 0, at 1 second it directly went to 20, and then at 1 second it directly went to 20, in the second it was just 30, and then it continued at 30, or then at 4th second it came back to 20 again. So what is the graph? The graph will something be like this. It will something be like this, right? So this increasing part is called acceleration. However, this decreasing part is called retardation. But now it is not increasing or decreasing at the same pace. First it increased directly till 20, then only 30, then came back, then remained at 30, then came back 20. Understood? Okay. Let's move to the very important topic now. From here, you will get questions, okay? You will get questions from this segment. It is a very, very important topic. How to find acceleration using velocity time graph. Now, remember a very important thing. Acceleration is what? It is change in velocity per unit time, right? Per unit time. Understood? Let me write it very clearly. Wait. This will be change in velocity per unit time. Now understand one thing. Remember the VT graph, velocity time graph. The V was at y-axis, time was at x-axis. And let's say this is my graph, okay? So if I draw a hypotenuse, if I join these two, you have not studied trigonometry yet, okay? Okay, let me explain you a little bit. There is something called slope, okay? There is something called slope of a graph. That basically means this angle, at what angle this graph is aligned with the x-axis. Let's say this is also another graph. The slope of this graph, A graph, will definitely be more than B because we measure inclination in slope. So this is more steep, and imagine you are on a mountain. This will be harder to climb because it's more inclined, and this will be easier to climb, right? So the one that is easier to climb will have less slope. The one that is harder to climb will have more slope. Okay, let's see now this graph. Okay, so this is velocity. Now one thing you have to remember, slope will be y-axis, y divided by x-axis. Now at y-axis we have what? We have velocity. At y-axis we have velocity. At x-axis we have time. So acceleration is v by t. The slope is also v by t. Acceleration is also change in velocity. You can write v divided by t. So acceleration is equal to slope of vt graph. Understood? With proper evidence I gave you. Acceleration is change in velocity by time, and slope is y component by x component. Y is velocity, x is time, v by t. So slope is also v by t. Acceleration is also v by t. That means acceleration is equal to slope of vt graph. It's written acceleration is slope of vt graph. Okay. Next we have velocity using displacement time graph. Now again, let's make a d and t. That is my displacement time graph. Again, this is the slope. This is the graph. Now slope of this will be what? Slope of this will be y component divided by x component. Now here y component is not velocity. Here it is distance. So y component is distance and x component is time. Understood? So velocity. Now let me know the formula of velocity. Velocity is what? Change in distance or change in displacement divided by time. That was what? Displacement is d, time is t. Now also velocity is equal to d by t, slope is equal to d by t. So velocity will be equal to slope of displacement time graph. Understood? As similar to acceleration equals to velocity time graph, acceleration equals to slope of velocity time graph. Similarly, velocity is equal to slope of displacement time graph. Understood? Okay, let's move on. This I need to correct a little bit. Actually, we have to find displacement from velocity time graph. So this is wrong. Wait. This, let me correct this. let me correct this. Now we have velocity time graph. We have velocity time graph and we need to calculate distance. See, there we had velocity time graph, but we were calculating acceleration. Now we have velocity time graph, same velocity time graph, but now we are not calculating acceleration. We are calculating displacement or distance. How to do that? Now, let's say this is the case or this is the case. Okay, wait. This is the case. Okay, this is my velocity that is increasing with time. Okay, now what will happen? See, displacement is what? Or let's say velocity. Velocity is what? Velocity is displacement upon time. Displacement upon time. That was my velocity, right? This is VT graph. Okay, now see very carefully. If I take this time and cross multiply here, that will become velocity into time. Velocity into time equals to displacement. Understood? Equals to displacement. Now see, very important thing. This velocity and time, let me make you understand first with this graph. Now, this shows that velocity is what? Y component. Velocity is a Y component and time is what? Time is X component. Time is X component. That means if I join this and if I multiply this Y component, that is my velocity, and this X component, that is my time, this gives me what? This is the area of rectangle or a square, length into breadth. This is the area, right? Length into breadth. Remember? So this actually gives the area under the graph. This gives area under VT graph. Correct? Understood? And this, my friend, is what? Displacement. So, if you have a VT graph and you have to find a displacement, that will be area under VT graph. There we had to find acceleration, we were using slope of VT graph. But to find displacement, we will be using area under, this whole area under VT graph. Understood? Very easy. You understood the point, the whole point of this? Okay. Let's move on to equations of motion. See, I think NCERT has removed all the derivations from the CBSE curriculum. Okay, so if your school is watching, I'll make a new video to just explain the equations of motion. Okay, but right now it's not in NCERT, it's not in CBSE syllabus, so we don't need to go into even the graphical representation or the calculus method of solving these equations. Calculus method comes in +1, I guess. So you don't have to worry about derivation, okay? You just have to worry about what I'm telling you right now. First of all, let's imagine that I am going again to get a burger, or you send your father again to get a burger. Now he's continuously going on a same velocity, or he's continuously increasing his velocity, okay? And when he comes back, he uniformly, let's say, uniformly decreases his velocity. That means in the first second, 10 meter per second, second, 20 meter per second, third second, 30 meter per second. So at the interval of 10 meter per second, he's increasing his velocity. And similarly for decreasing, that means acceleration is constant. Acceleration is constant, right? So the condition is acceleration should be constant. It should always be a value. Acceleration is 6 meter per second square. Acceleration is 4 meter per second square. It should not change with time. You shouldn't have a case where you see that acceleration was 6 meter per second. After 2 seconds, acceleration become 10 meter per second square. Okay, so that in that case, these equations of motion will not be applied. They will always be applied in one single case, and that, my friend, your acceleration should be constant. Then only these equations will be used. Now let's see the equations. Now, V equals to U plus AT. V is what? V is my final velocity. I'll do one numerical on this, don't worry. U is my initial velocity. U is initial velocity. S is your displacement. It is displacement, not distance. Remember, it is displacement, the shortest path, okay? Then A is your acceleration or retardation. Acceleration, or in any case if comes, it can also be retardation. Understood? Understood these three equations of motion. First is, how I remember these equations is to continuously say it again and again and again. V equals to U plus AT, S equals to UT plus half AT square, V square minus U square equal to 2AS. As you continue studying physics, or continue if you take science in your +1 and +2 as well, you'll see how easily you will remember these equations. They'll be engraved in your soul. V equals to U plus AT, S equals to UT plus half AT square, V square minus U square equals to 2AS. Now how to use it, that we'll see doing the questions. Let's do one very important question. Read it very carefully. A train is starting from rest. Okay, so the train here is at rest. That means U equals to 0. Initial velocity is 0 because it is at rest. Attains a velocity of 72 km/h. Now it has a velocity of 72 km/h in 5 minutes. From going from here to here, it took 5 minutes. Understood? Next, assuming that the acceleration is uniform, they have given acceleration is uniform, acceleration is constant. That means, okay, so acceleration is constant. Every time they'll give you an equation of motion question, they will mention that acceleration is uniform or acceleration is constant. Done? Next, find. What do we have to find here? We have to find the acceleration. We have to find the acceleration. First, we have to find acceleration and the distance traveled by the train for attaining this velocity. This distance, let's call it S. Okay, so we have to find the acceleration and we have to find the S. Now, let's go back to, or let's move ahead and let me write the equations again. V equals to U plus AT. S equals to UT plus half AT square. V square minus U square equals to 2AS. Now, I am given with what? Initial velocity, that is 0. Final velocity 72 km/h. And time. Time is 5 minutes. Okay, so which equation can I use to find either S or A? Now, let's see the first equation. I have V, okay, I have U, I have T, also I can find A easily. Can I find A easily? Now, we are using the first equation, V equals to U plus AT. But before that, one thing you have to take care of. You have to convert all the units into SI units. You have to convert everything into SI units. That means SI unit is what? Meter per second. And for time it is second. So U equals to 0 meter per second. That will be good. Now V equals to 72 km/h. How will you convert km/h into meter per second? That we'll see. See. Now, 1 kilometer has 1000 meters, right? 1000 meters. And 1 hour has 60 into 60 into 60 seconds. Understood? 1 hour has 60 minutes, then each minute has, oh, this is just 60. I wrote one extra 60 here. Yeah, 60 into 60 seconds. That means if I have to multiply kilometers to convert kilometers into meters, I have to multiply this by 1000. 72 into 1000 divided by 60 into 60 to convert hour into seconds. Done? Now, you just solve this. This cancels out and this becomes 3 and this becomes 5. 2 3s are 6, 2 5s are 10. Now, very important thing. Just leave this 72 out, the exact value that was given. What you have to do, simply multiply 72 with 5 divide by 3 into 6 is 18. So every time you want to convert kilometer per hour into meter per second, every time you have to convert kilometer per hour into meter per second, you just have to multiply by 5 by 18. Anything you have, let's say 80 kilometer per hour, so you'll have to multiply it by 5 by 18 and the answer will be whatever into meter per second. Understood? Okay, great. Now we have to convert this into meter per second. This 72 kilometer per hour we'll have to convert into meter per second. So what we did V equals to 72 into 5 by 18. Now this becomes meter per second. Now this goes, right, 18, how much on which does it go? I guess it goes on 4, right? 18 4 will be 32, 3, yeah. So 18 4s are 72. Right? So this is simple. 4 into 5 meter per second and this will be 20 meters per second. So velocity which was before 72 kilometers per hour, now it is 20 meters per second. Understood? And they'll give you basic calculation like this only, the multiplied with the ones that get multiplied with 18, so you can do the calculation very fast. Okay, you are not in some higher classes at this moment. So final velocity is 20 meter per second, and time, we also have to convert time into seconds. So time will be 5 minutes into 60 seconds, that is 300 seconds. So let's just write it again. Now V I have, U was 0, time is 300 seconds, and I'm using first equation of motion. So first equation of motion is V equals to U plus AT. V is given as 20, U is given as 0, A I have to find, T is 300 seconds. So this cancels out, this becomes 20 equals to A into 300. This is in multiply, I'll take this in divide, 20 divided by 300 and that will be A. This cancels out, 3 if you cancel this, this becomes 1.5. This becomes 1.5, that is opposite, I did that. Sorry, this will become 0.6666, okay, and there is one more 0, so this becomes 0.067 meter per second square, and that is my acceleration. Understood? You have to practice this calculation. Just simply cancel all the excess zeros, then leave this 0, just cancel out the values, and then this is a 0 in divide, so just put up in a point extra, right? This was 0.6, 1 0 extra, I wrote 0.06, and then I wrote with what do you say, what is that called? I forgot, like how you write 0.666 into 0.067, right? So you rounded it off. Okay, great. I forgot round off. Okay, next we have to find what? We have to find a distance now. Now let's again go back to the equation. Now I have all these things, but now I also have acceleration, which is 0.067 meter per second square. I also have acceleration, right? Now what can I find? I have to find S. Now this equation I can also use. I have U, I have T, I have half A T square, and this also I can use. I have V, right? I have V, I have U, I have A. Now in these two you can use any. Let's just use the second one. Okay, the second equation is S equals to UT plus half AT square. S we have to find. U was 0, remember? So T is anything into 0 will be 0, equals to half and into A. For now, let's just write A equals to 2 divided by 30. Okay, I'll tell you why I'm writing this. 2 divided by 30. See, it was 20 divided by 300. I cut 1 0, 2 by 30 remain. To get the answer, I solved this. But to use it in another equation, let's just use 2 by 30. And the time is what? 300 second square. Now this 2 cancels out. That is why I wrote 2 by 30. And now this becomes 1 by 30 into 300 into 300, right? So this also cancels out. This becomes 3 tens are 30. So this becomes 3,000, 300 into 100, 3,000 meters. So S becomes 3,000 meters, or you can write 3 kilometers. They'll mostly ask you to find the answer in meters or kilometers. So use according to that, or you can leave in any of these. 3,000 meters is also correct, 3 kilometers is also correct. But this is my SI unit. Okay. Now in the single question, you used two equations. You found acceleration and distance, and we also understood how to convert kilometer per hour into meter per second. Also, if you want to convert meter per second into kilometer per hour, so what you'll have to do, you'll have to, if you want to go back, you'll have to multiply by 18 by 5. Just the opposite, inverse of that. Just the inverse of that. If you want from kilometer to meter per second, multiplied by 5 by 18. From meter per second to kilometer per hour, multiply by 18 by 5. Understood? Okay, let's see what else is next. Yes, uniform circular motion. Magnitude of velocity remains unchanged, but direction is continuously changing. What is this? I don't have any thread, but let's say you have a thread and you tied a stone with it and you start rotating it. Let me show you. You start rotating it, then that motion, my friend, is circular motion. Let me. That motion will be, this motion will be circular motion. You know how to summon a ghost, and you do like this ghost is moving in a circular motion. This motion is called circular motion. Now, what is the importance of this motion, right? So this motion, so this circular motion, why is this very important to study? Because there is a very new tricky thing that is happening in circular motion. That is what? In the square motion, let's say, in here, you are going straight, you are changing direction. Okay, then you go straight, you are changing direction. Go straight, changing direction. In here also, you go from here to here, then you change direction. Go into a straight line, then you change direction. Go into a straight line, then you change direction. If you continuously adding all these these straight lines, the direction, the points where the direction change starts to increase, and that becomes a circle. At a circle, you are at every point. At every point, you are changing your direction. You are changing your direction. That means even if in the whole circle you are traveling by 10 meter per second, here also you are going by 10 meter per second, but we know acceleration is a vector quantity. Acceleration is a vector quantity. That means along with the magnitude also requires direction, and if the direction changes, the acceleration changes. Or if the direction changes, velocity changes, because velocity was also a vector quantity. So as in here, the velocity was 10 meter per second, and in here the velocity is also 10 meter per second, but the direction is changing at literally every point. From here, the direction is here, direction is here, direction is here. So at every point, the direction is changing. That means every time acceleration is also changing, because acceleration is a combination of magnitude plus direction. If direction changes at every point, acceleration changes at every point. That's why we say magnitude of velocity remains unchanged, but direction is changing continuously. And that is your uniform circular motion. Now, what do you have to study about this uniform circular motion? Just 2-3 things you have to keep in mind. First, the distance. If I am traveling in a circular motion, let's say I go from here, I am standing here or you are standing here. You travel the whole path and you came back at this point. And the radius of this circle is, let's say, 10 meters. Okay, radius is 10 meters. Now, what will be the total distance covered? Distance covered is simply 2 pi into r. That means 2 into 22 by 7 into r is 10 meters. So, this will be my total distance covered. But there is one more thing. If I start from here, cover the whole path and come back here, the displacement will be what, my friend? I came back to the same point where I started, so displacement will be 0. Understood? Let's take another case. Now, I just started from here and I went straight opposite. Now I'm here. So now what will be the distance I cover? So the whole distance divided by 2. So whatever this distance was, now the distance will be what? Distance will be 2 pi r divided by 2, right? So distance will be simply pi r. That is 3.14 into 10 meters. This is the distance. Displacement. On the other hand, see very carefully. If I draw a radius at this point and since it is directly opposite, I draw a radius at this point. If 2r is equal to what? It is diameter. This hole is diameter. So displacement is not now 0. Displacement is the shortest path. This is not the path he covered. This is the distance. But the shortest path, this path is displacement. Understood? And what is this displacement is? This is diameter. That is 2 into radius. Radius was 10. So 2 into 10 meters, that is 20 meters is the displacement. However, 3.14 into 10 is the distance. So distance is more than displacement, right? So displacement is the shortest path. That's it. That's all you have to remember in the circular motion. One more thing, let's see. See, there is one thing that you will learn in your further studies or you must have learned is a tangent. That means at any circle, there is a circle. At any point, if you draw a line that just touches that circle, at that one single point, like this. See? This line is only touching this point at just one single point. I can't zoom it. Can I? No. Okay. So it is touching at this just one single point. That this line is called tangent. And this tangent gives the direction. It gives the direction at that point. How? See, if again you have a rock tied to a thread and you are rotating it in a circular direction, if you let that go, will it fly in a circular motion? No? Or will it, if you let it go here, let's say the rock is here, it will not keep flying in a circular motion, right? If you let go of the thread at this point, this will go direct straight, right? So that straight is the direction of rock at that point in a circular motion. So direction of this point in the circular motion will be towards the tangent. And similarly for this point, this will be tangent, so direction will be this. At this point, direction will be this. At this point, direction will be this. And can you clearly see at each point direction is changing, right? That is only what circular motion is. So every uniform circular motion is accelerated because the direction is changing continuously. And by that, my friend, we end our first chapter of your class 9th, that is motion. Now this chapter is interesting. Coming chapters are even more interesting. So make sure you subscribe this channel. There is a link in the description. Go join that WhatsApp channel. Join that link and you'll get all the notifications. We'll be coming live as well. We are giving some of the strategy videos as well, so that you can be ahead of your peers. How to aim for 9th class, how to aim for 10th class boards even. So go watch those videos and let us know what else you want. If you are confused, if you are worried about anything, and make sure you subscribe the channel, like this video and share with your class friends as well, so they can also study motion in a manner that they can understand, and especially in English at Diksha Vedantu. I'm Aditi, your physics teacher, and I'll meet you in the next one. Bye bye.